Hello students, and welcome to today's video lesson on operations of radicals. First thing I want to talk about is some vocabulary. I want to talk about our radical symbol. Remember, we call the square root symbol a radical. One thing we've been seeing, we saw for the first time, was an index. So whenever I have a number here, this is our index. Yesterday we learned that, hey, we aren't always going to do square root. Sometimes we might have another index there, something else that we need to find groups of, right? The default value for the index is always 2, but something to keep in mind is that value may change. The next thing I want to talk about is the number underneath the radical sign. We call this the radicand. Remember, this whole thing we call a radical. So that is some vocabulary that you're going to hear me use throughout today's video lesson, and I want to make sure you understand what piece of the radical I'm referring to. So first thing we're going to do is talk about adding and subtracting radicals. So the first thing I need to know is that when I'm adding and subtracting radicals, they must be the same index and the same radicand. So they must have the same value in front of the square root and the same number underneath the radical. So let's go ahead into our first example. Here I have square root of 72 plus square root of 18 minus square root of 32. Here I see that all of these values have the same index, but they don't have the same radicand. So on a problem like this, do I just say, all right, I can't add this because they don't have the same radicand? Not quite. I always need to check and see if I can simplify them. So let's start and simplify these radicals and see if we can get them to a place where they have the same index and the same radicand. Let's start by simplifying the square root of 72 here. I know the square root of 72 is 9 times 8. If I simplify this further, I can take 9 to 3 and 3, and 8 to 4 and 2, and I can continue on with 4 to 2 and 2. So I could rewrite the square root of 72 as, when I have two groups, these get multiplied together. So 3 times 2 is 6. 6 root 2. So I've taken 72 and rewritten it as 6 root 2. Now I need to do that same thing here and see if I can get that same radicand. 18, its factors are 9 and 2. If I simplify that 9, I get 3. And look at that, I have that same radicand. So I can simplify square root of 18 to 3 root 2 and add that to my simplified square root of 72. I also need to check with 32 here. Here it has factors of 8 and 4. And if I continue here, I know that 8 has a factor of 2 and 4. And I can stop and say, hey, I already got my group of 2. So I could rewrite square root of 32 as 4 root 2. This negative stays with it. So I'm going to get 4 root 2. 4 comes out in front, 2 stays underneath. Now that I have the same index and the same radicand, I can go ahead and add and subtract these. One thing I want to remind you of is if I'm doing 2x plus 3x, remember the variable doesn't change. So 2x plus 3x, I just worry about the numbers out in front. 2 plus 3 is 5. And the variable stays the same. The same is going to be true for our operations on radicals. I'm not going to, when I'm adding or subtracting, I'm not going to change the value of the radical. Now the numbers out in front, they may change. So now let's go ahead and do this. Here I know 6 root 2 plus 3 root 2. I can just combine these numbers out in front. And I know 6 plus 3 is 9, so I can write this as 9 root 2. Now I still have to subtract that 4 minus root 2. I know 9 minus 4 is 5, and then that radical stays the same. So my final answer for that first problem is the answer 5 root 2. All right. Hopefully you find that helpful. Now let's talk about how I can do this again with a cube root. So I noticed that these do have the same indices. These both have that cube indices. So now I need to check and simplify these down and see if I can get that same radicand. So 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. Here I have one group of 3. Remember, with that index, I'm looking for a different group. So here I have one group of 3. So I can bring out one of those and multiply it with the number out in front. So 5 cube root 16 turns into 5 times 2, 10 cube root of 2. Now let's simplify our other term here and see if we can get that same radicand, since we already have that same index. Here 54 is 9 times 6, and I can bring this down to 3, 3 for the 9, and 6 I can break into 3 and 2. Here I see I have that group of 3. I have 3 3s, so one of those can go out and get multiplied with that 4 out in front. I know 3 times 4 is 12, so I'll simplify that to 12. This is a cube root of 2. Now I have the same index, I have the same radicand, so I can just worry and focus on these numbers down in front. 10 plus 12 is 22, and then my radical stays the same, so that's going to be cube root of 2, giving me my final answer there. All right. Next, I want to talk about how you can multiply and divide binomial radicals. For these, they must be the same index. So this is something in common between multiplying and dividing, as well as adding and subtracting. They must have that same index. I can't combine radicals if they don't have that same index. But when I'm multiplying and dividing, that radicand can be different. That radicand can be different. All right, let's get into our first problem. So here I have the binomial expression 4 plus 5, square root of 5, times 8 minus 7 root 3. So whenever I have a binomial times a binomial, I want to do FOIL. So I'm going to take and start by multiplying 4 times 8. Well, there I know 4 times 8 is 32. Next, I do 4 times negative 7 root 3. When I'm multiplying a number and then a square root like this, I worry about multiplying just the numbers out in front first. So I know 4 times negative 7 is negative 28. Now I multiplied just that square root by it. Next, I need to take that square root of 5 times 8. So here I worry about just the numbers out in front. 8 times 1 is 8, so that's plus 8 times that square root of 5. Lastly, when I have a square root times a square root, the numbers on front get multiplied. So 1 times negative 7 is negative 7. And then square root of 5 times the square root of 3, the numbers underneath here get multiplied together. So what is 5 times 3? That's 15. And that's what I put underneath my radical. I always want to get in the habit of checking here and seeing if I can simplify this last term and combine it with anything inside of here. Or even these terms, I might be able to simplify it throughout this process. Here, when I check 15, I know its factors are 5 and 3. Nothing to simplify here, meaning that this is my correct answer. All right, next thing I want to talk about is dividing radical expressions. Now, dividing radicals is not really what we're going to do here. What we are going to do here is rationalize the denominator. And what does that mean? Well, remember, all fractions are division problems. So what I actually am saying here is I'm dividing by 5 plus square root of 2. And if you plug in square root of 2 into your calculator, that's going to give you a really, really long number. That goes on and on and on forever. And I can't divide by a number that goes on and on and on forever. That doesn't make sense. So we need to rationalize this by getting rid of that denominator, or the square root in the denominator. So we can do that by using the conjugate. The conjugate is something you've definitely heard about in this class already with our imaginary numbers and i's. So a refresher on what the conjugate is. The conjugate is the same values. So here I have a value of 5 and square root of 2, but the number in between these changes. So I want to take and multiply the bottom by the conjugate. And remember, when I'm working with fractions, what I do to the bottom, I need to do to the top to keep them keep them equal. So I need to also multiply the top by 5 minus root 2. Now, on the top, I can just distribute that 6 in, and I know 6 times 5 is 30. 6 times negative root 2 is negative 6 root 2. So now I've gone and taken and distributed that 6 through. Next here on the bottom, I want to take and FOIL out the bottom. 5 times 5 is 25. 5 times negative root 2 is negative 5 root 2. Square root of 2 times 5 is plus 5 root 2. I see this term and this term can cancel. That's a good sign. Remember, I'm trying to get rid of all radicals in the denominator. I have one last multiplication part of this FOIL though. Square root of 2 times negative square root of 2 is going to be negative out in front. Now when I'm multiplying those numbers, those get multiplied together. And then can I take the square root of 4? Yes, it's 2 and 2. So I can rewrite this as 25. Now negative 5 root 2 plus 5 root of 2, those cancel out. Minus 2. 25 minus 2 is 23. So I put that 23 here. I do want to check, is there a number that can divide into 30, 23, and 6? 3 can divide into 30, 3 can divide into 6, but 3 cannot divide into 23, so because 23 is prime. So this is my final answer here for this division problem. Notice that we got rid of any square root in that denominator. All right, let's go ahead and move on to our next example. Here I have another FOIL problem, so let's walk through this. First I want to do 6 times 3, which is 18. Then I do 6 times negative 5 root 18. So I start by 6 times negative 5, that's negative 30, root 18. Next, I want to do negative 2 root 8 times 3. So I do negative 2 times 3 is negative 6. Now, then I have that square root of 8 on that. Now, my last multiplication part is the last pieces. Negative 2 root 8 times negative 5 root 18. That gives me a plus 10 when I do negative 2 times negative 5. 8 times 18, when I plug that into my calculator, I get 144. And now I am not done with this problem. I need to check these radicals and see if I can simplify them. Already 144 is jumping out to me, that's 12 times 12. So when I take that square root of 144, this 112 is going to get multiplied with the 12 out in front, and I'm going to be left with 120. Next, I want to try and simplify square root of 8. That's 4 and 2, and 4 is a perfect square of 2 and 2. So I could rewrite that as 2 times negative 6 is negative 12 root 2. Simplifying this negative 30, 18, let's check. I know 18 is 9 and 2, and 9 has factors of 3 and 3. So this 3 is going to get multiplied with that negative 90. 3 times negative 30 equals negative 90. So I get negative 90. Root 2 left under there. And notice how now I have the same index, same radicand. I can combine these. And last term is just bringing down that 18. I haven't done anything to that. I'll eventually combine that with the 120. Now let's combine our like terms here. So when I do that, 18 plus 120 is 138. Negative 90 minus 12 is negative 102 root 2. Giving that as my final answer for this multiplication problem. All right, let's do another division problem. On this problem, I need to multiply by the conjugate. So the conjugate here, I just take the same numbers. So this is going to be square root of 7. This is going to be 8. But what changes is that sign in between. This is negative, so my conjugate is going to have a plus in between there. And what I do to the bottom of my fraction, I need to do to the top. So I'm also going to multiply the top by that square root of 7 plus 8. Now, on this problem, I'm going to need a FOIL on the top, FOIL on the bottom, and simplify throughout that process. So let's start on FOILing on the top. 4 times square root of 7 is 4 root 7. 4 times 8 is plus 32. Next, on to my second term, the square root of 7. Square root of 7 times square root of 7. Well, that I multiplied just the numbers out in front, and I get the square root of 49. But I say to myself, hey, I can simplify that. That's just 7 times 7. So when I'm doing that, I'm just going to write plus 7. Next step, square root of 7 times 8 is plus 8 root 7. Kind of running out of room there. I'll try and clean that up on my next go around of FOIL. So that was me FOILing the top. I already see I can combine some like terms, and I'll do that in my next step. let's go ahead and finish our FOIL on the top here, and then we'll simplify both the top and the bottom on the next step. So when I do square root of 7 times square root of 7, we already said, hey, that's going to give me 7. Square root of 7 times 8 is plus 8 root 7. Negative 8 times square root of 7 is negative 8 root 7. Good, those middle terms are going to cancel out. I know that that's my goal here. I want to get rid of all square roots on the denominator, the bottom. Last part of my FOIL is negative 8 times 8. That is negative 64. All right, now when I combine my like terms here on the top, 32 plus 7 is 39. Now when I add my square roots, 4 root 7 plus 8 root 7, well, I know 4 plus 8 is 12 root 7. Now on the bottom, these terms with the square root cancel out. I'm just left with negative 64 plus 7. When I do that, I get negative 57. All right, now I need to check, is there a number I can divide into 39, 57, and 12? I can. I know 39 goes into, or 3 goes into 39, 3 goes into 12, and 3 goes into 57. So I'm going to pull that negative out in front. 39 divided by 3 is 13. 12 divided by 3 is 4. Now that doesn't change the square root. Now 57 divided by 3 is 19. So my final answer here is going to be negative 13 plus 4 root 7, all divided by 19. All right, I got one more problem for us to go over, and that is our square root problem. So remember, whenever I have something squared, it's the base times itself that many times. So this is not 6 plus 2 root 2. It's actually 6 plus 2 root 2 times 6 plus 2 root 2. So let's go ahead and do this FOIL really quick. One last example, then you can get started on your homework. First I do 6 times 6 is 36. Then I do 6 times 2 root 2. 6 times 2 is 12, so plus 12 root 2. Next, I do 2 root 2 times 6. That's again another plus 12 root 2. And lastly, I have square root of 2 times the square root of 2 times 2 times the square root of 2. So the numbers out in front are 2 times 2 is 4. And now underneath the radical is 4 as well. I can simplify this last one. 2 and 2, that gets multiplied, and I would write that last term as plus 8. I can't simplify that, but I could combine my like terms here. So I know 12 root 2 plus 12 root 2 is 24 root 2, and then I have 36. I have 36 and 8 that I can combine, leaving my final answer as 44 plus 24 root 2. Hopefully you found these video notes supportive. And if you have any additional questions, I have additional resources on my website, and I will be back tomorrow in class to help out with anything you are unsure of. I hope you have a great day, and I want to leave you with one math joke. Why do plants hate math? Because it gives them square roots. I hope you have a good day, make good choices, be nice to each other, and be nice to your teachers.